Hi everyone. To start off our semester, I would like to begin with a video on the arithmetic operations on whole numbers, integers, and then fractions. Since we have the use of calculators in our class, I decided for this method of review rather than taking class time. You will receive an assignment from me over this material whenever we're done with it. Okay, so first of all, the whole numbers. These are what we think of as the positive numbers including 0. I say including 0 because 0 is not positive, it's not negative, and that they keep going on forever. Okay. We're also going to use the integers. The integers are the whole numbers with the negative numbers added in. There's my 0, 1, 2, 3, 4. And the dots at the beginning and end here, we change colors. These are called ellipses, and they just mean that the number pattern goes on forever. It's going to keep going up and it's going to keep getting smaller. Okay, so these are our numbers. The operations that we're going to be talking about are just the normal operations you're familiar with. So we're talking about addition, subtraction, multiplication, and division. Now, multiplication, I drew a little star. It is an asterisk. I will always use an asterisk for multiplication, or I will use parentheses to denote multiplication. That's kind of a wonky parenthesis. In higher mathematics, we very rarely use the letter X. So you'll never see me write 3 times 2 in this manner. Unless we're in scientific notation, and even then I try not to do it, but we'll come to that when we get there. Okay. So addition. When we're talking about addition, you really just want to pay attention to the signs of your numbers. When you're adding two numbers that have the same signs, so same sign, okay, so I could have 4 plus 2, or let's do negative 4 plus a negative 2. Okay, so here I've got two different math statements. Right here in orange, I'm going to write negative 4 minus 2, because that's normally what we are used to seeing with subtraction. We don't really ever see this this right here. We don't like to see it anyway. We don't, two signs together can be confusing, but just so you know, they are the exact same statement. Okay, they don't mean anything different. So here you want to add the numbers, keep the sign. So in my first math statement, my 4 plus 2 here, both of these numbers are positive, so I just have to add up the integers. 4 plus 2 is 6. Okay, but because they're both positive, my answer here also has to be positive. In my bottom statements here, both of my numbers are negative. So I'm going to make sure that my answer is negative. 4 plus 2 is still 6, because remember, I'm just adding up the whole number amounts. So 4 plus 2 is 6. Since both of them were negative, it is -6. Okay, I didn't need that last. Okay, so when our signs are the same, we keep the sign, we add the whole number amounts. Let me try to erase this all at once. Okay, so adding with different signs. So if I can get my pen to work again, different signs. Okay, so how about -4 plus 2? Let me fix my 4 there. Okay, so one of my numbers is negative, one of them is positive. What I'm going to do here is technically subtraction. Okay, we're going to do normal subtraction, but we're going to keep the sign of the larger number. It's not a hashtag. I'm old. It's a number sign. Okay, so the pound sign. So in my head, I'm really thinking 4 minus 2. 4 minus 2 is 2. Okay. So up here, I know my answer is going to be 2, but remember, I said that we have to keep the sign of the larger number. So I have to think of 4 being the larger whole number. So I'm going to keep the sign that's on the 4. And since the 4 is negative, I have a -2 right here. Okay, let me erase part of this. That's not going to be quick. Okay, so I could have also had this written as 4 minus 2. One of my numbers is positive, one of them is negative, but this is just written as normal subtraction, so I'm pretty safe to say that's just 2. 4 being my larger whole number is positive, so my answer should be positive, and we kept it positive, so we're good there. Now, that was addition and subtraction. Let's talk about multiplication of whole numbers and integers. So multiplication. Again, I would like to focus our conversation about signs. I'm not really concerned with your ability to multiply, especially since we're going to be using calculators in our course. So I would like to help you make sure you're keeping your sign straight. Okay, so if I have multiplication, okay, and my signs are the same. Sorry, this pen's all wonky. And my signs are the same. Answer is positive. Okay. So a couple of examples. We have 4 times 2. Well, 4 times 2 is 8. Both of them are positive. Positive 4 times positive 2 gives me positive 8. Also, I could have written this as negative 4 times negative 2. Remember I said we were going to be using parentheses for multiplication. I have the same signs here. So that means my answer is still going to be positive 8. Okay. So when my signs are different, okay, so negative 4 times positive 2, or I could have 4 times negative 2. In each of these examples, one of my numbers is positive and one of my answers is negative. When my signs are different, my answer is negative. So this would be negative 8, and this one also would be negative 8. Okay. Let me change color here for a moment. One more thing that I want to bring up, you may consider it fairly obvious, but it's a math rule that we need to address, and that is multiplication by 0. Okay, so 0 times any number, we're going to say a. So a equals any number. We'll say real number. So 0 times any number a is always going to be 0. Okay? It's called the product property of 0. If you give me a moment to erase all of this, we will move on to division. Okay, so division. Again, we're not going to spend a lot of time in class doing hand division. So we will have the use of the calculator. Again, I would like to focus this discussion about the sign rules. Okay. So this may sound familiar when my signs are the same. My answer is positive. Okay. So 4 divided by 2. And I am going to use fraction form. You are going to really never see me use the division symbol like in this manner here. Okay. We will really be using fraction form a lot. So 4 divided by 2, but my signs could also be negative 4 divided by negative 2. And again, each of these examples, they have the same sign. So 4 divided by 2 is 2. Let me erase. So 4 divided by 2 is 2. Negative 4 divided by negative 2, that is also positive 2 because they have the same sign. Okay. Now when our signs are different, our answer is negative. Negative 4 divided by 2 would be negative 2, and 4 divided by negative 2 would also be negative 2. Okay. again, give me a second to erase everything. Another, not necessarily sign rule that I would like to talk about, but another example. So you've already seen me use a to mean any real number. Okay. Let's also include b in that definition, except b will not equal 0. So any real number not 0. So b cannot equal 0. Okay. And it can't because I'm about to talk about fractions. So if I have a fraction a over b, doesn't matter what these two numbers are as long as b is not 0. A could be 0. So I would like to talk another sign rule that's not always clear to everyone. Let's say I had negative a divided by b. I can move that sign all over the place because that's the same thing as a divided by negative b, and that is the same thing as negative a divided by b. So I could have my negative sign in the numerator, like so. I could have it in the denominator, like here. Or I could just pull that little guy out in front, right there. Okay, they all mean the same thing. Don't be worried about moving them around. There is only one of them here. Okay, one of the things from that last example, if I had negative 4 divided by negative 2, that negative sign cancels itself out. Okay, so that is the same thing as 4 divided by 2 times negative 1 times negative 1. That would just divide itself out. Okay, so when you only have one sign, it's okay to move it wherever you want to. Make it easier for you to see, you're right. Some people have a very big problem with having a negative sign in the denominator. It just looks messy. Okay. Again, give me a second to erase everything before we move on. Let me go up here and erase all this too. It's a lot of unusable screen, guys. Okay. Another rule involving fractions, we're still saying that a is any real number okay. As long as a is not 0, let's say that here, not 0. As long as a is not 0 here, 0 divided by a, this is 0. That is a perfectly acceptable mathematical statement. But a divided by 0, here a is any real number. This is something we call undefined. This is literally the answer if on a worksheet or quiz or something you see a divided by 0 equals. This is the answer I'm looking for, undefined. It is not 0. Okay? Moving right along. So I said I was always going to write division in fraction form because that's what fractions are. They're division problems. Let's talk about some operations on fractions. Okay? So multiplication of fractions. Let's say 1/2 times 1/3. Okay. When we have multiplication of fractions, it does not matter that we have the same denominator or not. So all we're going to do is multiply. So I'm going to take my numerators and multiply them straight across, and then I'm going to take my denominators and I'm going to multiply them straight across. Okay, so what I mean is I'm going to do this. 1 times 1 over 2 times 3. So 1 times 1 is 1 in my numerator, and then 2 times 3, that gives me 6 in my denominator. Okay, so multiplication of fractions is pretty straightforward. We are using a calculator in our class. So my preference, if you do not have an actual fraction button, is to not put in 1/2 as a decimal and multiply it to 1/3 as a decimal. My preference is that you multiply straight across the top. You input all of your numerators first to get that number, so you can write, this one here. And then you go back and you multiply the denominators across the bottom, so you get this number here, and then you can write it in fraction form. In one class, two of my classes, you may have calculators that do have fraction buttons, and that's a whole topic we'll talk about there. Okay, so that's multiplication of fractions. Notice I really didn't say anything about reducing. That's a topic for the classroom. Okay, let's talk about division of fractions real quick, just so we understand the operations that are happening. So I'm not trying to make swirlies there, computer. Okay, so division of fractions. So let's go back to our example that I just used, 1/2, but instead of saying times 1/3, let's do divided by 1/3. Okay. This is a multi-step process, I guess you could say. You don't want to actually try to divide fractions. We're going to do something that we like to call keep, change, flip. So keep, change, flip. So what am I going to keep? I am going to keep my 1/2. Okay, so that stays absolutely the same. What am I changing? I am changing my division sign to multiplication. And what am I flipping? I am flipping my 1/3. So that's 3/1. So remember that every whole number is a fraction over 1. And if you are a person who struggles with multiplying fractions out, you don't have to rewrite this as 3. It's perfectly acceptable to leave it as 3/1. That way you know absolutely where it went to and what's happening. But now that we've done keep, change, flip, we can multiply as normal. And remember, for multiplication, I go straight across the numerator. So I've got 1 times 3 over 2 times 1, which gives me 3/2. Okay, so and that would be my final answer. So I always thought it was a little weird that we have to kind of teach fractions backward. Now that we've discussed multiplication and division of fractions, we can move on to addition of fractions. So addition of fractions. And when I say addition, I am also including subtraction with that. So addition and subtraction of fractions, they have the same rule. And that is, you have to have a common denominator. So if I had a problem like 1/3 plus 1/3, here my denominators are both the same. They're both 3. So I just have to add up my numerators. My denominator is going to stay the same in my answer. So what I'm really doing is this, and 1 plus 1 is 2. That gives me 2/3. Now, if they don't have a common denominator, when my denominators are different, so 1/2 plus 1/3, here I want to find my least common denominator. Now, these are fairly small numbers. My least common denominator is a number that has both 2 and 3 as factors of it. So here it would be 6. 2 times 3 is 6. So I need to rewrite these fractions so that they have 6 in the denominator. Okay, so in order to make this 2 in my first fraction of 6, I need to multiply this by 3. Let's use green. So I need to multiply this 2 by a 3. And because I'm doing it to the denominator, I have to do it to the numerator. Okay, 3 divided by 3 here is 1. So I'm really multiplying 1/2 to the number 1. So I'm not changing it. I'm just changing the way it's written. Okay, so that's going to happen here. And the same thing for the 1/3. I also need to have this fraction have a denominator of 6. So let's change colors for this. I need to multiply that 3 by 2. And because I'm doing it to the denominator, again, I have to do it to the numerator. So this is happening 1 times 2 and 3 times 2. Okay. Back to black here. So 3 times 1 is 3. 3 times 2 is 6. I still have my plus sign. And then 2 times 1 is 2. 3 times 2 is 6. Okay. So now that I have the same denominator, I really just need to add the numerators. 6 is going to stay the same in my answer, and 3 plus 2 is 5 over 6. So if you have a fraction button in your calculator that you can use, normally this process is done for you, so you don't even have to worry about it. And again, that's a topic that we'll discover in class depending on what calculator you're using. Okay. That's all I'm going to put in this video. It's been about half an hour, I would say. I don't want to really overwhelm y'all. I will be doing another one about different topics to go through this first couple of weeks. That way we don't have to spend class time. So just consider this a short review. The worksheet that I give you over this material, please feel free to use your calculator. I highly encourage it because we need you to get comfortable with those calculators right away. If you're in statistics, then there's a lot of operations in there that you'll need to find and figure out how to use. And I don't want the actual math part of the class to be what's holding you up. If you're in quantitative reasoning, then you have a calculator that uses fraction buttons. So really our concern there is you learning how to input those things properly. If you have any questions, just let me know in class, or you can send me an email. The email address is in the syllabus. It's on Canvas, and I'm pretty sure I gave you a worksheet or a handout with it on there already. So if you have any questions, let me know. Thanks, guys.